Hi everybody, this is Mr. Nolan, and this is the next part of our series on how to graph fluxes. So in the last part of this series, what we started talking about was how do we use numbers in order to actually graph what our carbon pools are doing. So we're going to just go ahead and continue and look at two more that are sort of conflicting, but we'll look at, or I should say converse, that they're opposites. So what if we were to plant some trees? If we wanted to plant some trees, how would our fluxes change? Well, we're going to have more photosynthesis, right? Because we're planting trees and our trees are growing. We're going to have more photosynthesis, and over the course of that time, probably more photosynthesis than respiration. So let's say that we start with 800 units of inorganic carbon and 400 units of organic carbon. After planting some trees, what's going to happen? Well, let's say that our fluxes are 300 pounds or whatever unit, 300 pounds of inorganic carbon are going to be turned into organic carbon because that's photosynthesis. You're pulling carbon dioxide out of the air. And then you have 200 pounds per year of cellular respiration. And in that case, our organic carbon, such as sugars and foods, are being converted into carbon dioxide in order to make energy for our living things. So we're going to get 300 units of carbon into our organic, and we're going to lose 200 from our organic. So if we were to try to indicate what this ought to look like by showing our positives and negatives, what we would see is that there is a positive flux into the organic carbon, and there's a small negative flux. And then over here, we see a large negative flux and a small positive flux for our organic, or for our inorganic compounds. So that's what we would see. So we can probably anticipate that our organic carbon is going to get bigger, and our inorganic carbon pool will shrink. So that's what we can anticipate. Let's go ahead and graph it and see if we can't figure out how to deal with this. So here's our graph that we're going to use. We're going to start off the same way that we did previously. And so I'll kind of get this set up for you to save you a minute. Okay, there we go. So we're going to start off with 400 pounds or units of our organic carbon and 800 inorganic, and then so that makes our total 1,200. So if we jump back to the previous slide, what we'll see is that we're saying that our trees are planted, so we're actually going to have an increase in organic matter over the course of the study period. So let's go ahead and use the same strategy that we used from before. So my organic carbon is going to see an increase in 300 pounds, and it's going to see a decrease in only 200. And so if we were to go ahead and add that up, what we would find is that we have a surplus or a positive net flux of 100. So if we add 100, so to 400, we're going to get 500 after a year. If we went ahead and did the same thing to our our inorganic carbon, we're going to start off with, we're going to actually lose 300. We're going to pick up 200. And that's a net flux of negative 100, which means that our inorganic is actually going to shrink to about 700. So we kind of see a decline there. And as usual, our total is going to stay the same. If we were to continue this rate, now we have to keep in mind, unless otherwise stated, in this scenario, our rate is going to continue. There's nothing that says that, well, now we're going to chop down our trees. It says it's going to continue. So if we just go ahead and extend this thinking for the next year, it's really easy to figure out what should our numbers be next year. What's probably going to happen is that we're going to be down to 600 for our inorganic carbon for year 2, and we're also going to be at 600 for our organic in year 2 as well. So we actually see that they end at the same mass, and of course our total remains the same at 1,200. So all the while we're actually losing carbon from the inorganic, and it's showing up in the organic, which is why we end up with 600 pounds at the end of our study period. So this is how you would graph this scenario. Just take a look at what is our fluxes, what do they do. If the fluxes are going to remain the same over the study period, just continue that same pattern. Let's do one more example to finish things off. Okay, for the last example here, let's think about something really traumatic, something that's really kind of a big disaster, something like a forest fire, a wildfire. So we've got this fire going on, and let's say we have a really bad year, like, the last couple of years in California have been. We just have a really bad year, and we've got our organic woods, we've got our inorganic, and we do have some photosynthesis going on. We also have a lot of burning, as well as some cellular respiration. So we've got a lot of carbon that's fluxing out from the organic into the inorganic, and we only have a little bit that's actually being photosynthesized that year. And then, our next year, we end up with kind of a reversal where we have some regrowth. And so for the next couple of years, we actually have our forest fire that's sort of or our forest, which is regrowing. So that means that our photosynthesis is going to increase, and maybe our cellular respiration will be a little bit lower. So suppose that we have these parameters. Okay, so we're going to go ahead, we've got our graph here, and we're going to go ahead and we'll start you off at the same numbers that we began at, 400, 800, and 1200. Okay, there we are. And we want to think about what are our positive and negative fluxes. So we're going to treat these exactly the same as we have in the past. Our organic had a negative flux. It was a whopper. So we had all these forest fires going on. So we actually had a negative flux of 400. And to that, we're going to add a positive flux of 100 because that's all the photosynthesis that was going on. And so our net flux was actually negative 300, so pretty bad. So we are going to go from 400 all the way down to just 100 at year one. We're not quite at 0, but we're at somewhere around like 100, pretty low. And if you haven't figured it out by now, our inorganic carbon is going to see a mirror image. So we actually have an increase of 400, and we have a decrease. So we're going to add minus 100 to that, and we're going to end up with an increase, a net increase of 300. And so our inorganic is actually going to go from 800 all the way up to 1100 in year one. So pretty significant change. But now let's say that our ecosystem kind of calms down a little bit, and this is what has occurred. We've actually lost a lot of our organic carbon to inorganic. So really, these arrows represent flux, right? We have our net flux. We're losing our inorganic carbon to, or our organic carbon to inorganic. And now let's go ahead and take a year and say, well, let's say that now our new numbers. Our forest is going to start regrowing. So in the number that I showed you earlier, we're going to have positive 300 for the organic and then negative 200. So let's see what happens there. So we're going to take our new numbers. We're going to have our positive 300 and negative 200 plus negative 200, and that's going to give us a net increase of 100. So we're going to go from 100 up here to 200. So we're starting to recover. And then our inorganic, this one, we are actually going to gain 200 and lose 300 because those were our parameters that we established. So our net flux is actually going to be negative 100. We're going to end up losing 100 so that we end up with just 1,000 in year two. So this is where we end up going. And the reason why that happened, why we actually went down over the course of this study period, is because the inorganic is starting to give back some of the carbon that it took when the forest fire burned. So as that carbon starts to flux back into the organic realm, the inorganic is actually going to lose a little bit of that carbon. This is a rather more complicated example because we have a few different rates going on, unlike the last one where it was the same rate over the course of the study period. So I hope that this was enlightening. This helps you to see how you're supposed to figure out fluxes for these graphs. The important thing to recognize and to remember is that if we're graphing fluxes, just identify and graph the starting size of each pool. I was doing that for you with the 400, 800, 1200, and it depends what is given to you. The starting size won't always be the same. It depends on what's given to you. I figure out what your fluxes are. Where are my organic and inorganic fluxes? Are they positive, negative? What are those numbers? Calculate your net fluxes for each pool by adding them. Don't worry about doing all the silly subtraction. You might do it in the wrong order. Calculate the change of each pool size. That's your net flux, right? The change in the pool size is really going to just end up being the net flux. And once you've calculated the new pool's size, just go ahead and graph it. Graph the new pool size for whatever years you need to. And then you should be able to graph your fluxes. It doesn't matter what kind of situations you end up with, whether it's a forest fire, or you're growing trees, or what you're doing. You should be able to graph fluxes as long as you follow these steps.